In this demonstration, we're going to be using still the same good old CM5 CarBot over here, but we're going to use some new design feature to it. The first thing, it will be using something called behavior control approach, and I hope you have read the book by now so you can see what we mean by that. Essentially, we're going to roll out behavior that have certain goals. This program also using IR sensor directly, right, center, and left instead of using the obstacle detector flag. This is to adjust individually sensor if we need to. We set all the moving speed to 500, which is somewhat a little bit less than 50%. Backward and avoiding time I set at 3, meaning 3/8 of a second. Escape time is set to 5 or 5/8 of a second. The timer with 8, the time counter, if you set it 8, equals to roughly a second. We're going to see a two type of turn, pivot turn. That means the wheel on the turn side are locked. So essentially, it is a very wide turn. What I call rotate turn, and then the wheel on the turn side turn the other way. So essentially, it's turn within itself or spinning within itself more correctly. So it's a tighter turn. Okay, so those are the features. Let's look at the code. First call initialize motor, and initialize motor. Yeah. Here we go. So initialize motor and just have a loop, for loop. By 0 the address A just to make them sure that they are in wheel mode. And then we have various parameter setting. Forward speed set to 500, backward speed set to 500, turning speed set up to 500, backward time set to 3, meaning 3/8 of a minute, second, avoid time 3/8 of a second, escape time 3/8 of a second. And then we have the endless loop. So if you remember the previous, maybe you have seen the obstacle detection car demo, you see that the endless loop, we had an if-else-if structure, very big if-else structure. And when you go behavior control, you can see that the code looks very different immediately. And what it does, it will tend to have like parallel if. The first if here on statement 17, essentially saying, hey, if you on the IR on the left is bigger than 200, that means there's something to the left of the bot, or if IR right bigger than 200, that means if something is on the right. So notice this one is an or. That means only a single thing can be on the left, or a single thing can be on the right, or they're both things on the right and the left. So this is the or. If that case happens, and you call it something avoid side, you need to trigger your behavior that to avoid something coming from the side of you, or there's an object coming from the side of you. And once you're done with that, there's another if on 19. And you check if the R center is 252, that means something very close to your nose now, you better escape. And then you notice this call forward doesn't have any if attachments attached to it. So this is the default behavior. So it go forward as a default behavior all the time. And you notice what everything is inside the endless loop. I mean, when it goes in, it check to see if something on the side of it. Yeah, it is. It check. It's trying to avoid something on the side. And then even if it's done, it will check to see if something in front of its nose or not. If it's not in front of the nose, it will escape. So depending on what the situation are when actually the robot run, both if statement here or both if condition can be triggered. And so it will avoid side first and then escape. If none of these if statements are true, that means everything is clear pretty much, it will default behavior go forward. So in the behavior control, usually you always have a default behavior and then have special situation that trigger specific behavior, and you treat them that. It is important, and you can leave that to your own exercise. You can try to put escape in front of the avoid side behavior and see how does it affect your bot. That will be interesting to see, but that you can leave that to your own exercise. Let's have a look closer at avoiding side. So remember, the avoiding side will be triggered when the robot detects something on the left or on the right or on both. So avoiding side in here, when it goes in, it check again because when it trigger avoid side, that means there's something on the left or something on the right or both already. So when it goes in, just to be sure again, it check to see if the left side reading is bigger than the right side reading. That means the object on the left is closer than the object on the right, if in the case you have two objects. But if you don't have anything on the right, it would trigger it just avoid right. But this is broader condition because it can handle when you have a situation where you have both objects on the left and the right, and the one on the left happen to be closer to the robot. And then the correct behavior, of course, is to avoid right, to avoid by going to the right. So you see in this airfield structure, so one of these cases only triggered at any one time. You see the else part of it is when the object on the right is closer than the object on the left. Or that means there's no object on the left at all. And then obviously you can avoid by going to the left side. And then it's finished with the return. Escape. Escape always first, you go backward for backward time with 3/8 of a second. So essentially, when you need something too much in front of your nose right now, too real close, that means you got a cul-de-sac, and then that means what? First you go backward for 3/8 of a second, and then you check again, similar behavior to your voice side. You check to see if the right bigger than the left. That means something is closer to your right. Turn left too. That means you spin in place to the left. And remember, when you escape, you are very close to the nose now, so you are in tight corner. So you have to use a different kind of left than the regular left. Shall we say, complementary condition for it to do is when something, the object, the obstacle is closer to the left and to the right. That means obviously you're going to turn right and make a spin right to get out of it. The L, that means the object about left and right object are about the same, and then you trigger else. And here called turn right too. Here this is a choice. I just happen to be favoring turning right because I'm right-handed. But if you're left-handed, you probably can call this one called turn left too also. That's no problem. And then you delay escape time, which is 5/8 of a second, called the delay and turn. So the escape behavior, you go backward for 3/8 of a second, and then turn left or turn right depending on the situation that the IXS1 tell you about which object or which obstacle is closer to the right side or left side, and you turn the behavior properly for 5/8 a second. And then you're done. Okay, so we're ready to download. The code. So, okay. Now let's go back and leave it here so you can see. So I gotta turn it off, unplug that, turn it on, play mode, start. It will go forward, but now if I leave my hand in front, you see it will turn, and it won't go that behavior anymore. So we're trying to stay away from it as much as possible. So even if I block it completely here, so you can get away. Everything clear? See its favor to the right, you can see that? So let it go, and then I suddenly stick something in front of it, you see it turn to the right and get escape. In this demonstration, I want to show you the same smart avoider code, completely unchained, that we use to design to avoid obstacle. But then how did that behave when it put into a maze like this? So keep going straight pretty good. All right, not too bad. So I set it up to set a track, so it got stuck in the cul-de-sac to see how it behaves. Sometimes it can get out. So you can see this behavior control. I didn't design the behavior smart enough so that it figured out a cul-de-sac. So when it figured out that a cul-de-sac, I had to go backwards some more because it can do anything. Oh, it's still kind of stuck in the mud there. Oh, maybe. So it kind of stuck there. Let's give it a little help. There we go. And then it's stuck there. Needs more coat in there. Okay. Finally get out.